Today our new word is dilation. This should be something we've already seen though in Unit 3 with scale factor. So you'll notice the first sentence for us says similarity. It says something that produces a similar figure. So under a similar transformation, such as dilation, it's the original figure, but it's a different size. Okay, so all a dilation is it enlarges or reduces the image by a scale factor. So you'll notice in this example, point P, my triangle was to the right side of it. So when it did the dilation from point P, it got bigger and expanded in that same direction. Okay, this figure should also look familiar from Unit 3. Okay, so if I get bigger in this direction, we could say the scale factor is times 3, for example. Or if I'm getting smaller, say it was going from this shape down to that one, we could say my scale factor is times 1/3. Remember, we never write as division, we say we times it by a fraction. I also made that little note to myself. Dilation means the same thing as scale factor. So what's true about the angles? If we think back to when we did this last time, the angles have to stay the same. For example, if this angle down here was to get bigger or smaller, then my triangle would open up or shrink down inside itself. So these two angles, right here for example, need to still stay the same, but the side lengths will get bigger or smaller. Bigger or smaller. And my directions, that's what it means by enlarges or reduces. Enlarges that it gets bigger, reduces that it gets smaller. Therefore, dilations always create similar figures. Similar meaning it's the same shape, but it's bigger or smaller. If you think back to yesterday, congruent is when they stay the exact same size. Today, when it gets bigger or smaller, that's what we call similar. It's still the same shape, but not the same size. So let's go ahead and try an example. Below, you'll see some ordered pairs. I see a small triangle down here that has the A, B, and C, and then my new one has the little tallies behind it. We have A1, B1, and C1. So in order to find the rule, I'm going to do the ordered pairs first because that helps me. So A, for example, is at 2, +1. And my new A is at 4, 5, 6, 1, 2, 3. From right there, we can already see what happened to both my X's and my Y's. Let's try another one to be sure. So my ordered pair for B is at 5, 1 for my original. My new one is all the way over here at 15, 3. Hopefully we're seeing it. My last one for C. I have the ordered pair 3, 6. And my ordered pair for C1 is all the way over at 9 and then up to 18. So it's up to you if you'd like to write down all those ordered pairs to help you. The important thing to note is that every time, what happened to my X's and Y's? X's and Y's, X's and Y's. Both the X and the Y both got times by 3. So you'll see it written as 3x, 3y. For my scale factor though, it's okay to just say times 3. Okay. Just remember, if it happens to get smaller, say this was my original, and I went down to this was my new image, then my rule would be times by 1/3, and I would have both 1/3 times x and 1/3 times y. My x's and y's have to both be times by the same thing. That'll make the whole shape grow or shrink. If these were times by different things, it could make it either taller or wider. As long as they're both times by the same thing, something bigger than 1 will make it bigger, or if they're both times by something less than 1, so a fraction, then my shape will get smaller. The angles will stay the same, but the size of my shape will change.